In this video, I'll be talking about the concept of scales of measurement. Not all variables have the same nature and not all variables contain the same amount of information. Some variables have more information in them, and that's because of the scale of measurement of the variable. Scales of measurement allow us to describe the nature of information within the values assigned to the variables, and that is based on the particular scale of measurement that the variable uses. So it refers to the amount of information contained in the data, and if you know the scale of measurement of a particular variable, it normally allows us to identify the most appropriate way to summarize and to analyze that variable. Now, there are two main categories for the scales of measurement. We have qualitative or categorical scales of measurement and quantitative scales of measurement. For qualitative, we have two. We have the nominal or nominative scale and the ordinal scale. And for quantitative, we have interval scale and the ratio scale. For the first scale of measurement, called the nominal or the nominative scale, this refers to a qualitative variable for which there is no meaningful ranking of the categories, meaning the variable segregates the elements into multiple categories, but these categories have no ranking, meaning there is no category that has a higher ranking or higher importance as compared to the other categories. Now, data are labels or names used to identify an attribute of the element. Usually, it refers to the value of the variable itself. And here, a non-numeric label or a numeric code can be used for the nominal variable. Some examples are in the Ateneo de Manila University, we have 4 schools in the Loyola schools. And this is an example of a nominal scale of measure, a variable that uses the nominal scale of measurement, because we know that this is only a way for the school to categorize the students according to their fields of study. And there is no understood ranking, or there is no difference in terms of ranking among the 4 schools. Therefore, this is considered as a nominal scale of measurement. The program of the students in universities also follow the nominal scale of measurement. So again, here, it's just a way to segregate or to categorize the students according to their particular program of study in the university, and there is no uh, ranking between those programs, making that a variable following the nominal scale of measurement. Now, a mobile number is also a variable that follows the nominal scale. This is a numeric code. However, this is not considered as a quantitative variable because it's not measuring any quantity. It's only used to make a distinction, or to make an identification for a certain owner of that number, and the use of the variable is really more of a qualitative variable. And the mobile number follows a nominal scale of measurement because, again, the value of the variable itself, whatever the combination of the number is, does not mean any ranking. Therefore, it follows a nominal scale of measurement. The second scale of measurement for qualitative variables is the ordinal scale of measurement. Here, this refers to the scale of measurement for a qualitative variable for which there is a meaningful ranking of the categories. So that's the main difference between nominal and ordinal. For nominal, there is no ranking between the categories, but for ordinal, there is ranking among the categories. Here, the data have the properties of nominal data, meaning it's also qualitative. It segregates the elements into multiple groups. However, rank of the data is meaningful for these kinds of variables. Now, a non-numeric label or a numeric code may also be used for ordinal scales of measurement, and some examples are the Latin honors in universities. In Ateneo de Manila University, graduating students can fall into 4 categories for honors. There is the highest, which is summa cum laude, followed by magna cum laude, followed by cum laude, and honorable mention. Now, these Latin honors are representing different categories, and here we know that there is meaningful ranking between the categories. Obviously, the cumulative QPI of students who are part of the summa cum laude group are higher as compared to the cumulative QPI of those students in the cum laude group. So again, Latin honors is a variable that follows the ordinal scale of measurement. Now, faculty ranks also follow the ordinal scale of measurement. An example are the faculty ranks in Ateneo. So here are the different categories for the positions of teachers in the Ateneo de Manila University. So the lowest is the lecturer. This is the position normally given to part-time teachers in the university. And then we have assistant instructor. This refers to the position assigned or given to full-time teachers of the university who don't have graduate degrees yet. Instructor is the position assigned to full-time teachers of the university with graduate degrees or similar certifications or similar experiences. And then assistant professor is the starting position of a full-time teacher with a doctorate degree. Now, the succeeding positions are just promotions of the earlier positions mentioned based on the years of service, the amount of research produced or contributed to university, and also the service done to the university. Now, there's a special position given to teachers in university, and that's the professor emeritus rank. And this is normally given to retired teachers of the university who used to have a full professor ranking. So technically, it's incorrect to call all of your college teachers as professors because only a few people in Ateneo de Manila University have this ranking or any other university. Now, again, the faculty ranks follow an ordinal scale of measurement because it allows us to categorize the students, to categorize the teachers according to their experience, their years of service to the university, and their educational attainment. And at the same time, it follows an ordinal scale because there is ranking among these categories. So the highest ranking is the professor or the full professor. And again, this has a higher ranking compared to all these other positions here. Another example are options in a Likert scale. So you might not be familiar with the term Likert scale, but this is something that we normally encounter, especially when we answer questionnaires. So in the course and faculty evaluation for your different courses, normally you are asked to answer those kinds of questionnaires towards the end of the semester. And in those questionnaires, you can see different statements, and you have to make a selection among multiple choices. So there are options such as strongly disagree, disagree, neutral, agree, and strongly disagree. Now, those are options in a Likert scale. So that's what we call as a Likert scale. And again, this is ordinal. This follows an ordinal scale of measurement because first, it makes a distinction between the five different choices. And at the same time, there is ranking among those choices. So one choice, particularly strongly agree, has a higher value as compared to the other options in that Likert scale. Now, for the third scale of measurement, we have the interval scale, and this one is a scale of measurement for quantitative variables only. So, an interval scale of measurement refers to variables where the data have the properties of the ordinal data, and the interval between observations is expressed in terms of a fixed unit of measure. First, the property of ordinal data that this is referring to is about the ranking. It means that if the value of the variable is higher or lower, then that has an implication. It means something. There is difference in terms of the ranking because of the difference in the value of the variable. And as mentioned also here, since the variables that follow an interval scale of measurement are quantitative variables, the values are expressed in terms of a fixed unit of measure. So there is normally a unit of measure attached to the value of the variable. Since this refers to quantitative variables, interval data are always numeric, and then one unique characteristic of an interval scale of measurement is that there is no defined zero. When we say that there is no defined zero, it means that a variable can assume a value of zero, but it does not mean that nothing was measured. It means that zero is just a point in the line. Zero is an assigned value for a particular case, and it does not mean that nothing was measured. So that's one unique example of one unique characteristic of an interval data. And an example of that are temperatures in degrees Celsius. So if you can recall, we have a value for temperature in degrees Celsius which is equal to 0, and we know that as the freezing point. And we know that even if the temperature in degrees Celsius is equal to 0, it doesn't mean that there is no temperature. 0 degrees is just the point, or is just the value assigned to the freezing point. That's why this is considered as an interval data. Now, another unique characteristic of an interval data is that the interval, or the difference between two numbers, will make sense. But if you get the ratio or the quotient between two values, that value will not make sense. An example of that is the date of the month. For example, you are comparing March 1 and March 5. So if you compare the interval, or the difference between those two values, again you have March 1 and March 5, the difference between 1 and 5 is 4. And we can make sense of that difference. We can say that 4 is the number of days in between March 1 and March 5, or that March 5 is 4 days away from March 1. So we can make sense of the difference because it's an interval data. However, if you compute for the ratio, or the quotient between those two numbers, the value will not make sense. So if you look at the same example, March 1 and March 5, the ratio between the two is either 1 over 5 or 5 over 1 or 5. And again, we know that there is no way for us to interpret that value. We can't say that March 5 is 5 days away from March 1, or March 5 is 5 times longer than March 1. Again, there is no possible interpretation for the ratio because the variable follows an interval scale of measurement. Now, the last scale of measurement is the ratio scale of measurement. And for most quantitative variables, they follow the ratio scale of measurement. So this is the more common scale for quantitative variables. Here, the data have all the properties of interval data, where again, a higher or a lower value means something, and that the ratio of the two values is now meaningful as well. So as compared to an interval scale of measurement, there is a defined zero value, meaning if the value of the variable is equal to 0, it means that nothing was measured, or there is no quantity really for that variable. And at the same time, it also differs with the interval scale because now both the interval and the ratio between two numbers will make sense or can be interpreted. So an example of this can be distance, or height, or weight, or net worth. So again, all of these variables are following the ratio scale of measurement because again, there is a true zero value. For example, if your variable refers to the amount of money in a certain savings account, and if the value is equal to 0, it really means that there is no money, there's no amount left in that account. So there is a true, or there is a defined value for 0. At the same time, the ratio between two numbers will also make sense. So if you are comparing two roots, let's say you have one root which is uh, uh, 10 meters, has a total distance of 10 meters, and another route with a total distance of 50 meters, we can compute for the difference between the two, which is 40, and we know that 40 will make sense. So route B is 40 meters longer than route A. At the same time, the ratio between the two numbers will also make sense. So if you're comparing 10 meters and 50 meters, you can compute for a ratio or a quotient of 1 over 5 or 5, and you can make sense of both numbers. The distance of route A is 1/5 of the total distance of route B, or route B is 5 times longer than the distance of route A. So those are the properties of the ratio scale of measurement. So here in this slide, I have the top 10 richest Filipinos as of 2017, according to Forbes magazine's Philippines 50 richest list. And here, again, net worth is an example of a variable that follows a ratio scale of measurement. So we can see here that the top the richest Filipino is Henry C. with a net worth of $18 billion, followed by John Gokong Wei Jr. with a net worth of $5.5 billion, and so on. As mentioned earlier, net worth follows a ratio scale of measurement because the difference between two net worths will make sense, and even the ratio between two net worths will also make sense. So let's simplify the net worth of John Gokongwei. Let's assume that this is equal to $6 billion. Now, if you compare $6 billion of John Gokongwei to the net worth of Henry C., which is $18 billion, again, both the difference and the ratio will make sense. So the difference between 18 and 6 is 12. So Henry C. is $12 billion richer than John Gokongwei Jr. And at the same time, the ratio between the two values will make sense. So 18 over 6 is 3, meaning Henry C. is 3 times richer, or has Henry C.'s net worth is 3 times bigger than that of John Gokongwei Jr. So again, a ratio scale of measurement has those two features. You can interpret a value for 0. There is a defined 0 value, and that even the quotient or the ratio between two numbers will make sense.